Thank you very much. For those who aren't familiar with the Defense Innovation Unit, I work for the Secretary of Defense, and what we do is we accelerate the adoption of commercial technology to transform and improve the way we do operations, and in doing so we build and grow our industrial capacity for doing things. So long history of technology evolution between Silicon Valley, Department of Defense, academia. So we're part of this ecosystem to try to rekindle and accelerate that. So for the crowd today, what are we really focusing on in space in my organization is really this: building enduring advantages in space for economic prosperity and collective security. That's collective security is everybody, and it's not just the United States. And we do this, say this because this is something that warms people's hearts, that everybody says, well, yeah, collective security is good, economic prosperity, very good, especially want to go to Mars. So really, I want to raise our awareness above the most immediate problem. Lots of good science is taking place, a lot of commercial capabilities is allowing us to map very fine, even sub-centimeter debris in Earth orbit. And we're learning this, and we're recognizing that ignorance, when we do things early in science and technology, can create problems. So we're focused on solving this problem, but this is the man-made problem. I want to make sure that as part of this space domain awareness and active debris mitigation, we also think about the natural problem, right? So there's near-Earth objects. We flew the James Webb Space Telescope, put it into a gravitational well, if you will, and of course there's debris there. It's been pelted by micrometeorites. So places that we think are great places to live in space are also debris is a big problem. So and then of course if you look at our commercial. We're in a fourth industrial revolution where we're seeing really off the charts growth in technology areas that is also benefiting from the emergence of hardware and software. With our ability to do advanced computing and have software agility. But if you see here, we're rapidly getting to a point in the upper right side of the chart. To about 1 million metric tons of upmass per year. And that's before Starship is really getting going, that's 100 metric tons on a single launch if it gets optimal. And the cost of launch is coming down significantly. So it's really important. This is a great juncture for us to kind of get a hold of this problem. So what are we doing about it? Ignore the title of the slide. I did this late at night, so I didn't change the title. But these are things that we're actually doing to mitigate debris. And active debris removal on purpose is at the bottom of the list because it's really, really hard to do. So what are we doing? Improving our detection and tracking capabilities. My friend from Leo Labs is in the room, and we put some significant investment in the Leo Labs early on, and we're benefiting from that. So we have very accurate and timely ways to track debris, which is quite dynamic, much more so than people think. Developing in-space maneuverability. If the first two bullets combined is what you need for space traffic management. So if we want to create the addition of debris, we need to deconflict in space between our controllable objects and the uncontrollable debris. Third, we want to improve technology for aiding in the disposal of things that we put into orbit at end of mission, not end of life. And that's very important, as well as deploying payloads into their mission design orbit. Right now, we do a lot of rideshare. Rideshare is great for education, but if I fly a high school student experiment, let's put it in the lowest orbital plane necessary so that at the end of the school year, we can dispose of it rapidly and not have any consequence. Transform space operations to reusable platforms. This is probably the most important thing because if you, we don't want to create new debris. And even worse, I'm very passionate about this, is that we don't want to export this problem to other worlds. We already have debris in Martian orbit, but the moon has no atmosphere. So everything that we we put out there. My hair goes on fire when we had SLS deploy, experimental CubeSats at the moon. It's like the most reckless thing possible. So because that's going to land in somebody's backyard someday, right? So what we need to do is we need to challenge the way we think, and to Carol's problem, maybe adopt some ethical standards for how we do things. We could do that. We're doing that in AI. We have ethical standards. We actually helped to write ethical standards for AI at DoD. But how we employ and use these technologies in a way so that we're thinking about the consequences in the future, and then I've long said, putting my military hat on for a second, it's like you're not a true black belt in space if you can't solve like the most wicked problems. And the most wicked problem right now is like somebody's tumbling upper stages and other things those are like real hazards. There's a lot more of the sub-centimeter debris, and we'll figure out how to mitigate that. But probably the best thing to do is just avoid it. So, one more minute. So. I don't want to just say, identify the problem and say we're not doing anything about it. We're actually doing quite a bit about it. And the way that we work is we put money on small companies and medium and actually very large companies that are working on technologies to help solve the problem. So in general, we're transforming space operations to we want all reusable capabilities. Everything that goes in space is repurposed. It's either brought back down, or it's moved to a junkyard, or sent to the moon for future exploitation. But we want to get rid of the garbage auras and clean them up. And the way we're doing that is we need outposts, we need transport vehicles. So we have a hub and spoke logistics architecture that allows us to not just put things out in space, but then reclaim them and repurpose them. We can do decadal studies of Mars by having reusable spacecraft that go and do all kinds of sensing and then come back to a host and then get repurposed and then sent out with maybe newer sensors. So now we have agility in our science programs. Interfaces, propulsion, and robotics, all key technologies that we're putting there. But I think the most important thing is, we say space is a tyranny of volume. So these are important problems that we need to solve. But in terms of the question I would pose to you is that the most important things that we're doing in space today are really the commercial things. And what we need is a commercialization model that's sustainable, that says that I can close a business plan on active space debris removal. I don't think we're there just yet. Okay.
Wonderful. Okay, questions? Yes.
I'm just wondering if anybody is thinking about property rights models for long-lived orbits, like around the moon or in geostationary.
I was so happy to hear the lawyer who's not practicing law, space law today. Anytime you do anything with technology, you have to pay attention to policy. We run into policy barriers all the time. It's like we got to get ahead of this. So property rights, all these things. Right now, there's the wonderful thing that space offers us is there's very little precedence. So we can actually define the rules. It's really important that we get out there first and be responsible and set standards of conduct and what real property means. But most of the debris is still owned by the three countries that put most of it there: China, Russia, and the United States. I'm going to go back.
So given that you're the Defense Innovation Unit, I'm assuming that in order for you to get involved in some kind of project, there has to be a kind of obvious defense-related or national security-related component to that. But to what extent can you get involved in like dual-use kind of technologies where there's an obvious commercial or
National security is an umbrella. Includes economic security, safety for humans. If there is a NEO object and we need to do something about it, we probably have a lot of instruments at our disposal. So but I think you'll find for us, at least my organization in particular, we actually spend more time outside of the Pentagon working with the commercial sector to solve tough problems. And the wonderful thing is, that's why it's so important, the dual use, which you mentioned, is really that we need a commercial nexus to everything that we do.
Well, the specific question, I guess, was I was intrigued by seeing, Moon and Mars
Yeah.
on your view graph. I mean, can you really extend your reach to consider, Mars-related?
I can't build a moon. I can't build a defense base on the moon, but guess what? I can check into a moon hotel. I can travel about the moon. I can probably buy some resources at the moon, and then I can go to Mars and do the same thing. I don't know if there's a restriction on Mars just yet, but we don't live in a world of civil military fusion in the United States, but there's other ways for us to tackle that problem.
Okay, Bucky, we've sort of had this discussion before because,
Yes.
I've been working in this field in the past. I wonder if there's an update on this. When I was in the space situational awareness and space traffic management and debris milieu, there was a problem because the main source of information for about the trajectories of objects in Earth orbit was what's now the Space Force. It had a different name back then. And they had a conflict. On the one hand, they wanted to make space a safe environment for all players. On the other hand, they wanted to ensure US space superiority in a military sense. And that caused them to be not forthcoming with the best data or the most complete data. Has this, or even to incorporate data from outside any military systems, such as from our company, which operates a lot of satellites. Has any of this changed, or is this conflict still kind of a big stumbling block?
Briefly, I'll say it doesn't really matter so much anymore. I'm an Air Force guy. I wasn't in the Air Force Space Command like Pete, but I'll just throw my 2 cents at it. One is that remember this
in the real
the rapid rise of technology. Commercial technology there's 4 times more investment than there is for government space technology. And the wonderful thing, and I'm at DoD and we're still discovering the cloud. We're not using. So the whole thing is that the way that industry, especially the most innovative pockets of industry, is solving tough problems. I had a conversation earlier. Is really space domain awareness, which is everything, and of course the Space Force, everything is inside of GEO. So they have stars painted on a dome at GEO. That's their view of the universe. So they're not thinking about the consequence of NEOs and other things like that, but industry is. And the other thing is this: is that the data sets you can either buy them or they're widely available. The most exciting thing that's happening right now is multi-phenomenology. How everything in space. Everybody sees the globe and these little dots around it. Well, they don't. If they put the error bars in, it's really grotesque. So the whole thing is we're reducing all those error bars by using ground-based, space-based, GPS, other phenomenology. So ultimately, we can shrink those error bars down. And then what does that do? That expands the volume of space between these things, and with maneuverability, we can be more responsible about how we do things. So we don't even know the 6 degrees of freedom of most of the things that are really the most hazardous things in Earth orbit. But I think the reminder, though, if I go back to the natural threat, is what's happening in James Webb Space Telescope is probably not debris from satellites, right? So we need to understand more about the consequences of debris in gravitational wells and vibration points around every place else, so that we can avoid those threats for humanity in the future.
Thank you so much.